I hope that everyone who's peer reviewing this finds this helpful. So a first order linear differential equation is one that can be written in the form dy over d of x plus pxy equals q of x, where p and q are continuous functions of x. You want to make sure it's linear, where you have, for example, 2xy is going to be your p of x and x squared is going to be your q of x. You can't have square root of y because that does not satisfy pxy. That makes it nonlinear. So the integrating factor method is where you have your ODE form and multiply by an integrated factor u, where ux equals e to the power of px, the integral of px dx. This converts it in the form where you multiply everything by u, and then you integrate to get uxy and divide by u of x. I put x instead of t, my bad. And to solve for y. So in this example, we have the integrating factor method, where dy over d of x plus pxy equals gx. And then we have the example problem. We have a p of x and a g of x, so that satisfies that. Then you use the integrating factor, e to the integral of px dx. So this would be e to the integral of 3 dx, which equals e to the power of 3x. Multiply all of it by u. Make sure you pay attention to the product rule here, where d over d of x times uy, that's what you get for all this, equals ug of x. So in this, we would get d over d of x times e to the power of 3xy using the product rule equals e to the power of 3xx. Then we integrate both sides, u times y equals the integral of u times gx dx. So remember, g of x is just x. So e to the power of 3x times y equals the integral of e to the power of 3x x times dx. Then the integral of that is going to be x times e to the power of 3x over 3 minus e to the power of 3x over 9 plus constant c, divide by e of 3 of x, e to the power of 3 of x, and you're left with y equals x over 3 minus 1 over 9 plus c over e to the power of 3 of x. So in the initial value problem for number 6, we had t y prime plus y equals sine t, and y times pi over 2 equals 1. So you want to rewrite it in a standard order linear form, and then you get y prime plus 1 over t y equals sine t over t, where p of x is 1 over t, and q of x is going to be sine t over t. You find the integration factor by taking ut times pt equals u prime t over u times t equals utpt over u of t. The way I did it was I used just natural log, where natural log ut prime equals u prime t over u of t. And since natural log ut prime equals p of t, I just made natural log ut prime equal to 1t, and then natural log u of t is equal to the integral of 1 over t dt. So that's going to be your integral right there, 1 over t dt, and then when we use the common integral, you get t. Multiply by the integration factor y prime t to 1 over t yt equals sine t t over t. You want to just plug in t all there, and then you apply the product rule, where ty prime equals sine of t. So then when you work that out, you get ty equals the integral of sine t dt, and that equals negative cos t plus c1. That's your common integral. Ty equals negative cos t plus c1. Isolate to get ty over t equals negative cos t over t plus c1 over t. You're going to cancel out the t here, and then you're going to get negative cos t over t plus c1t. Then you apply your initial conditions from the original equation, where you plug in t, making t equal to pi over 2, and then you get this right here. And then you're going to use y pi over 2 equals 1. So we're going to have it equaling 1 equals negative cos pi over 2 over pi over 2 plus c1 pi over 2. cos pi over 2 over pi over 2 equals 0 when we use the trivial identity and the fraction rule to get 0. So when you switch your sides, you're going to get negative 0 plus c1 over pi over 2 equals 1. c1 over pi over 2 equals 2c1 over pi. When you use the fraction rule, you don't count the 0 because it's 0. And then you get 2c1 over pi equals 1. And then you're going to multiply by pi, and then you get 2c1 equals pi. So the constant that you get is going to be pi over 2 when you work that out. So that's what we use for the equation. Plug in the constant of pi over 2 into the equation, and you get negative cos t over t plus pi over 2t. So that's the way I worked out number 6. That's how I came to the conclusion of pi over 2. I hope whoever peer reviews this finds this helpful.